Hello. Hi guys, good morning. Welcome back. Or good morning, good evening. Welcome back to the new video. We have discussed all three problems previously: 2855, 2856, and 2857 of the bi-weekly contest 113. We are discussing the last problem. And again, you can just go and write the problem name by Aryan Mittal or just problem name Aryan Mittal. You can just easily find the problem. We are seeing minimum edge reversal so that every node is reachable. Again, I'll not say it's the hard problem. It's actually more or less kind of duplicate of a previous problem which we have seen previously in one of the contests and also in our graph intuition building playlist series. Cool. If you have not watched it, just go and write graph intuition building playlist by Aryan Mittal. You can just simply go and find that. Again, we'll simply see this problem. We have a simple directed graph with n nodes labeled from 0 to n minus 1. Again, the graph would form a tree if its edges were bidirectionals. So basically, it's a directed graph, but you can just assume if you just cannot see these edges as directed, if these had been undirected, so it would have to form a tree. That is one of the prime thing, that the input is generated such that if the edges were bidirectional, the graph would have been a tree. So I just say that, okay, the graph is not a cycle, it is actually a tree. So considering that you cannot see the edges as being directional, just assuming, okay, it is bidirectional, it is just like this, like this, like this, it will ultimately form a tree, which means it will have exactly n minus 1 edges. And that's also from the problem itself, it has exactly n minus 1 edges. Cool. So now we have got to know, okay, it's a tree with the directional edge. Now I am having an integer n and a two integer array called as edges, where edges of I is ui comma vi. So basically I have just edges array. It's just saying I have an edge from 2 to 0. From 2 to 0. It is a directional edge from 2 to 0. Again, represents a directed edge from 2 to 0, going in from node ui to node vi. Now again, the prime thing is edge reversal. An edge reversal changes the direction of an edge, that is a directed edge going in from node ui to vi becomes a directed edge going in from node vi to ui. Now when I say I apply an operation of edge reversal on this, now this, it is from 2 to 0, it will become a 0 to 2. That is what an edge reversal in this case means. So again, lastly it just says for every node I in the range from 0 to n minus 1, your task is to independently calculate the minimum number of edge reversals required so that it's possible to reach any other node starting from that node I through a sequence of directed edges. Just says ultimately that just give me the number of edge reversals required for all the nodes such that it's reachable to all the nodes, which means for 2 it can reach to 1, 2, 3, 0. Edge reversal required are 0. For 0 it needs to reach to all the nodes. It can reach to 2 but with one edge reversal. Okay, 1 can reach 1 for sure, can reach 3 for sure. Okay, nothing required anymore. From 1 I can just say, okay, I need to reach to 2, I need one edge reversal. Okay, cool, one edge reversal that I can directly reach, cool. Answer is 1 for this. For 3, if I just want to find the answer, okay, I'll reach 1 edge reversal, I'll reach 2, okay, again one edge reversal, I'll reach 3, okay, directly. Okay, so answer is for 3 answer is 2, for 2 answer is 0, for 1 answer is 1, for 0 answer is 1, and that's why I can simply see that the answer is 1102. Number of edge reversals required so as to reach. Now again, the constraints easily shows you that you cannot apply this edge reversal operation for all of the nodes. You can apply for one node, for sure you can apply for one node, but not for all the nodes. So again, firstly let's build a better example. So I use this example, like it's not a better example, it's nothing but just make an example, and from that example itself we just extend that example to any other thing. So let's say I just choose this as an example. Now again, I just made this example incrementally. How incrementally I showed you. Okay, like let me first make it. I'll just then show you how I made it incrementally, but simply just, okay, you can just increase the example length as much as you want, just so as to show you. Now Again, I'll just stick to this example for now. But what I'm just saying here is I can go in for sure. I can go in on one nodes to find what is the number of edge reversals required for that node. Let's say I just assume I will find and go number of edge reversals required for node 3. For node 3, number of edge reversals required, if I want to go, then I will have to kind of traverse the entire tree considering this as the root node. So if I have to go and I'll consider this 3 as the root node, now my task is ultimately from 3 as the root node, go and reach all the nodes. Now, Aryan, but from here you cannot even go anywhere. No, I can go. It's just that the cost of this operation for going from 3 to 1 is actually 1, which means I will have to reverse it, and this reversing will give me a cost of 1. So, okay, Rn, which means that, okay, I can have bidirectional edges. It's just that this particular edge is already there, so the cost is 0. But if I make a bidirectional edge, which means edge in different directions, so it cost will be 1. Okay, it is coming, cost is 0. So what I did was I assigned a variable, or basically a value, to every edge, saying, okay, opposite edge, because I actually will reverse the edge, so its cost, although, so as to move freely in my tree, I have to make it bidirectional, but I cannot make it bidirectional blindly. So I just assign a cost to those edges. Okay, that is a 0 cost, and that will be a 1 cost. Now I need to, as I'm saying, I will start from my root node. Aryan, but what is the how it will help you to start from only one node? Basically, I'm just, okay, ultimately in future I was said to start and do this operation for all the nodes. So let's at least find out for one node, right? Maybe I can just find something in between, who knows. So at least for now, just to find the answer, I'm just starting out from one node and try to find, okay, for this particular root node, as my root node, what is the number of edge reversals required for this node 3? Answer should be 2. Let's go and find out. Okay, I can just go, I'm just starting from this node. Okay, let's change the color with blue. I'm starting from the node 3. Okay, I can go to 1, but with a cost of 1. Okay, cost of 1 I have got. Okay, cool. From 1 I can go to 2, but with a cost of 1 again. Okay, my ultimately now I have 2 as the cost. From 2 I can go to 0 with a cost of 0. Okay, again it is, the cost ultimately is 0. Oh, Aryan, I have got edge reversal, or basically the cost I have got as 2 for 3, for node 3, but for that I had to traverse the entire tree. Okay, that is the case which I have got, but okay, I have got the cost as 2 for node 3. Did you notice one thing? That while you were traversing, you were actually maintaining the track of how much cost I had to incur if I had gone from 3 to 1. Which means if I just break this previous step down again, from 3, my cost was 0 initially. I went on to 1. I incurred a cost of 1. From 1, I went to 2. I'm concerning only from 3 itself. I incurred a cost of 2. Again, from here to here, I went on, but no cost was incurred. So ultimately the cost was 2. So you saw, if I can just store this value from 3 to 1, Aryan, but you're only concerned of the entire tree. So when you find the cost ultimately 2, so why you're storing the cost at every step? Because if the cost incurred from 3 to 1 is actually 1, as you can see, the cost incurred is 1, and I have stored that simply. The cost incurred is 1. I have stored that cost, and you can also see that 3 is just one step down of 1 is just one step down of 3. Okay, it is something like this: 3 and 1. Its cost incurred is 1 to reach from 3 to 1, and it's also one step down. So if I just ask you, if I had to go back to 3, how much cost I would need? Its depth is 1, cost incurred is 1. So which means the edge. Now I am now guessing the edge by using these two things, that how many number of straight edges are there, because now my main task is to reach from, the cost incurred was from 3 to 1, right? And depth is also from 3 itself. 3 is the root, 3 is the bap. From 3 it is a depth. Now ultimately I'm just trying to figure out how much cost I can reach from 1 to 3. In 1 to 3, if my cost incurred is 1, which means the edge for from 3 to 1, it would have been like this. Only then the cost incurred would have been 1, because for 3 he would have to reverse that edge to make it as a edge that he can go to 1 for sure, which means I can go to 1 without any cost. So this give me from 1 to 3, this gave me a cost as 0 only by using the variables of depth, that how much I am at the depth of 3 and how much I am at the depth and how much cost have been incurred from 3 as a root node. So you saw that, okay, while you are finding the answer for one root node, you can just keep track of the cost incurred at every step. And that cost incurred at every step, it can help you find the cost incurred if I go on from 1 to 3 back. Now Aryan, again, okay, you can just get to know the cost incurred from 1 to 3, but ultimately my task is to go on from 1 to every other node. So what I will do, wait a second, in last step you had gone from 3 to all the nodes. So if I'm saying, okay, I can reach from 3 to all the nodes in the cost of 2, and from 1 to reach 3 I am incurring no cost, but to reach from 3 to 1 I incurred a cost of 1, right? I incurred a cost of 1 here, right? And in total, to reach in the entire tree, my 3 needs a cost of 2. So for sure, the remaining cost required for 1 will actually be 1. I'll show you by the formula, exact formula. That's the reason I just made this tree, because it is actually very small and confusing, but still I'm just giving you a sense of how we are finding. Ultimately, we just started from very scratch, although we know, okay, we could not go and find for all the nodes what is the cost incurred, but we started off with one node. We started off with a node and assumed this as a root node and found out what is the cost incurred if I go on in the entire tree. Now, when I was going on the entire tree, I just thought of, okay, I'm going on the entire tree. Now, I have to repeat the same process again for all the nodes. Rather, what I could have done is, okay, if I'm going on from the root node to all the nodes one by one, so I can keep track of the cost incurred up till that point. Okay, I've got the cost incurred up till that point, cost incurred. Right? Now, when I've got the cost incurred up till that point, I can just bring out again from 1 back to 3 what was the cost incurred by just getting the cost current incurred from 3 to 1 and the depth required. Now, let's see how this is solved. Again, I assume my 1 as the root node. Cost incurred here is 0. Going on to 5, cost incurred is 1. Again, I'll just not draw the opposite arrows, but just imagine I'm going on from 1 to all the nodes. My main task is to go on from 1 to all the nodes ultimately. Cost incurred is 1. Cost incurred 0. Cost incurred again. Now, Aryan, how you will solve it? Simply a simple DFS where you start from the root node and pass in the root values. Cost passed 0. Although the opposite, it was the sign, so edge value would be 1. So for sure a 1 will be added to the cost, and you can just simply pass on the cost forward. From here it will again do a DFS to actually 6 and 3. Again the cost is opposite, so cost incurred will be 1. Cool. Cost incurred will be again 0 because it is just straightforward. Cost incurred will be 1. Cost incurred will be 2. That is, we have made a cost incurred. Again, with this cost incurred, I will also keep a global variable just to make sure that the total cost incurred for this one is actually 1 for this, 1 for this, and 2 for this. Or I can say, okay, 1, 2, 3, and 4. Total cost incurred. Total cost incurred for 1 is actually a 4. Now comes the interesting part. Now, let's say if I ask you from 1, you can reach anywhere in the entire tree whatsoever. So, let's be sure, okay, if anyhow you are able to reach 1. So, for sure, from 1, you can also always reach all the nodes. So now I make sure, okay, I am at 4. I will try to reach back to 1. And from 1, I know that, okay, in the cost of 4, I can reach back to all the nodes. So I'll just say, okay, from 4, how much will be the cost to reach to 1? But the cost here mentioned is it is from 1 to 4. Now I want the cost from 4 to 1. Simply for that fact, I should know how far is 4 from 1. For that, I will keep track of a variable called as depth. So depth is actually 1. Here the depth is 0. Just a simple DFS and just see, okay, how much is nodes deep. Its depth is 1. Its depth is 2. Its depth is 3. Its depth is 4. Its depth is 5. Just making sure simple DFS to actually know and find the depth. Now, I found the depth. It is at the depth of 4. The cost, okay, 0, 1, okay, it's a depth of 2. It's a depth of 3. Because simple DFS, it will just value will go to here, 1 depth increase, same value go to here, 1 depth increase. Sorry, it will be a depth of 4. Now, again, 1 cost incurred, depth is 3. So again, just saying, if here would have been bidirectional edges, so you would have reached in 3 steps down, but from 1 to 4, you had to flip one of the nodes, one of the edges. So from 4 to 1, you have to flip 2 of the edges. Simply a difference of 3 minus 1 is actually 2. Simply saying, okay, I will have to reverse 2 edges. And you can see also, you will reverse this and you will reverse this. Cool. Now you have got a number which is the cost, and simply using the depth and the cost incurred, which you have already stored in a array. With this, you have got the cost dash, which is actually simply a difference between depth and cost. To say from 4, I will require a cost of 2 to reach to 1. Now, can I blindly add a cost of 4 to reach to all the nodes? No, I should not. Why? Because you can see this cost of 4 is having one cost of this edge also, which was lying in between this path, right? So make sure your cost incurred from 4 to 1 is actually a 4. Your cost incurred, let's remove this. Your cost incurred from 4 to 1 is actually a C dash of 2, which you have found the cost. Now from 1 to all the nodes, the total cost incurred is actually a 4, but you have to make sure, okay, from 1 to 4, whatsoever is the cost, please remove that cost. So from this total cost, I will remove the cost from 1 to 4, because I cannot take this cost because I have taken from 4 to 1. I have gone, so I will not take from 1 to 4 wala cost. So from this total cost, I'll remove the cost from 1 to 4, and that 1 to 4 wala cost I have stored in C. So I just remove that. It will be 4 minus 1. It will actually say me, okay, the remaining cost is 3. I can easily see the remaining cost 3 says that I will not consider cost in this path entirely. I will not consider the cost here. Remaining cost is this one cost, and this one cost, which I will ultimately say, okay, I have 3 as one cost and 2 as one cost, which means from 4 to 1, the cost required is 2, and from 1 to all the other nodes, the cost required is 3. Simply add that, get an answer of 5, which is the cost required for going on from 4 to all the nodes. So ultimately, recapping what we learned, that firstly, we will mark any node as a root node. Now, again, for my case, in my example, I started my root node with a node having like this, which is having just one edge downwards. But you can start off with any of the root nodes. That's not compulsory at all. It's just that, okay, I just marked a root node starting like having just one edge as a root node. It is in my code which I have written, but still that would not be required at all. You can still assume any node as the root node. Now, when you have got the root node, simply start from that root node and find the depth to all the nodes and the cost incurred also to all the nodes. Now to find the cost incurred, simply while making my graph itself, I know, okay, I have an edge from 5 to 1. with a cost of 0, and 1 to 5 I'll also put with a cost of 1. So basically it is a simple adjacency list saying, okay, 5 is just a node, and I have a vector of pair saying I have a node to 1 with a cost of 0, right? And with 1 I will say, okay, I have a node to 5 with a cost of 1. That's how I can simply keep track of all the nodes and their cost. Just saying, okay, an edge has a cost now. Okay, now let's say, sorry, it was like this, right? Yeah. So now I have made blah, blah, blah. Yeah. Now, sorry, it just got hang. So I just was saying, cool. Now I have made the edges and I have assigned the cost. So I'll just simply do a DFS traversal, simply going and updating my cost, even storing that cost in a variable, so as to look back at that cost later on. I'll keep and go and do a simple DFS traversal and update the cost at every step. Now, also making sure to keep track of the total cost ultimately, because it will actually be required in the end, right, to find the cost for all the nodes. Now I have gotten the cost for one node. That is perfect. Now I have to go and simply do a simple loop operation. I'll do and try for all the nodes. Let's say I started from although the indexing was from 0, but here I showed from 1, no worries at all. But yeah, I'll go and try for all the nodes. Let's say for node 4, as I showed you, I need to simply firstly find from 4 to start a node, what is the cost? Simply saying what is the depth minus what is the cost from from start node to the current node. So let's say it is my current node is 4, my start node is 1. In my code also I have marked the node as start node as my root node, and the current node is just my node I. So it is my node I, it is my start node. So from start node to I, what is the cost? I have stored that. I have stored the depth also. So the cost from I to start a node will actually be depth minus cost. Okay, I have got this particular cost. But again, I have to go from 1 to all the nodes, excluding the path from start node to I. So I know the total cost from start node to all the nodes. It is an entire cost, but I exclude the cost. I'll exclude the cost from start node to the ith node, because I have already assumed I am going from I to the start node. So I'll just get another cost, which is starting from the start node, going on to all the other nodes, excluding the ith node, right? I have got the cost. I'll simply sum up the cost going on from 4 to start, which is going on from ith node to start node, and from start node to all the other nodes except the ith node, which means except the ith nodes and the nodes in the path of the ith nodes. I'll just go and find my answer, which is the sum of these two values. Cool. Let's quickly jump to the code itself. I could not get time to actually get the clean code from Leetcode, so it is my not so good dirty code. Please bear with it, because I had to leave for some place in a minute, so I had to just wrap up and give you my code. But yeah, again, it is not the cleanest code, but yeah, it is a short code, not that big, so that's the reason. Cool. Again, I just made a graph. You can make graph any whatsoever. I make from unordered map int to actually vector of pair of income int, where actually it is a source node to the destination node and the cost, right? Cool. I'll just say you can again here you will just see I just assumed and try to make my start node as a node having just one edge. Although you can start from any node whatsoever, it will still work. Cool. I went on to all the nodes and I push back. I know, okay, I have an edge from U to V. So U to V has a cost of 0, but V to U will have a cost of 1. And simply here, again, that's not necessary at all. You can just start from any node. Now you will see, okay, I have a depth array, a visited array, and an edge reversed array. Just saying, okay, what is the cost? It is a cost array, as I showed you. Edge reverse. Just saying, okay, the cost array. Now ERSN is edge reversed starting node. That's a variable name. Edge number of edge reversed for starting node, which is the total count in my variable. It is a total count. It is the count, right? Count array. Now I just simply do a DFS from this start node with the parent -1 graph as an input, visited as an input, edge reverse, which is the count array, as an input, 0 as the current depth, and depth as the actual depth array. Now, when I go into this particular, first a simple DFS, visited as true, depth as D. Now go on to all the neighbors. If the visited is false of that particular node, just simply update the count. As you saw, update the count. How we update the count? Count is simply the count of parent plus, if the edge is reversed, which means if the 3 to 4 edge has a cost of 1, simply add that cost onto your parent's cost, which means I'll just have that from parent's cost, which is 1. I'll simply add my cost of this edge. So I simply have the parent's cost. I added the, simply if that cost is 1 or 0, it will simply add that, else it will simply forward that value. If it can be the 0 or a 1, right? So simply add that cost value and simply getting the child's edge reverse or the cost value, and also updating the total count. If whatsoever edge I have to reverse, I'm just updating my total count, which is edge reverse starting node. Ultimately, again calling the DFS function for the neighbor node as a parent, graph visited, edge reverse as same, t plus 1 as the new depth, depth as the array. Now when I have got my total count, so I know I start from this node, so starting node has the count as this total count. Cool. I updated my answer. I went on to all the nodes. I have already found the answer for the start node, so I'll not use the start node. I'll go on to all the other nodes, find the value which is from ith node to the start node. This is the cost required. As I showed you, depth minus cost of I. Now, from the start node to all the other nodes except in that ith nodes wali path, this is the total cost minus the cost of I. As I showed you here also, where is this gone? Total cost minus cost of I, right? Same will be a value 2, and that's how I can simply add for answer of I, value 1, value plus value 2. Simply reiterating the answer because that will find the answer for all the nodes. Again, that was the easy question, easier than the question number 2 according to many folks. But yeah, that's pretty much it. Thanks for watching. Bye bye.